All right, in this section, we're going to be talking about game objects and components, really the most important things that make up your Unity scene. Virtually everything in your scene, 99.9% of everything in your scene is a game object. Sans things like, maybe the sky inside of your scene. Just about everything also is a game object. Game objects are everything. It's very important to understand this concept. If you're a .NET developer, you can kind of think of it as the system.object of Unity. In other words, virtually everything stems from a game object. Whether it's a particle system, a 3D model, even a 2D image, a light, a heads-up display, everything is what's called a game object. It is a particular type of object in Unity. And in a nutshell, a game object is simply an object that has a name, a tag, which is just some text, and a transform, which has position, rotation, and scale. Transform is very important. So a game object has these properties. Has a name, see right here, has a tag, which is just some text that we'll talk about in a second, a layer you can assign things to, and a transform. Transform is the most important property inside of Unity. It says, where in space are you? We talked about Unity having a left-handed coordinate system, so some x, y, and z value. In other words, there is a 0, 0, 0 in coordinate space, which is the center of your scene, center of your world, and this is its relation to that center point. Rotation in degrees, and the scale of your object. With that said, let's go ahead and look at a game object inside of Unity. And we can really look at a bunch of different scenes for this. Let's create a new scene and create an empty game object. You have the ability to create an empty game object. Now, why would you do that? A game object, again, here we have a name, a tag, and there's a bunch of tags that Unity gives us out of the box. A tag is just simply text that we can assign to a game object. It's another way of naming our game objects, and at runtime we can ask for any game object that has a tag of player or a tag of zombie, and we can create our own tags. There's all of our own custom tags, but a game object so it has a name, a tag, a layer. You can apply objects to different layers for different reasons. Visibility, for example. They can be on different layers for physics reasons, and we'll talk about that a little bit later. And here's transform, the position, rotation, and scale. Now, an empty game object can, let's double click on that, can be really invisible here. You can only see it when you click on it because you get the indicators to move the object, which is what this icon is here, the move icon, which I can click on my arrow tips and move an object around. Now, this game object has no visual properties, so when I click away from it, it disappears. An empty game object is a great thing that you can use for a spawn point. It just represents a location in space. A game object can be a container for other game objects. A game objects can also have components to make them do things. We'll talk about components next. We can also assign a little icon using this little drop-down menu here to a game object. So for example, if I wanted this to represent a spawn point in my scene, now when I click away from it, I can see that spawn point icon. If I ever get lost in Unity, I can always just double click on an object, and it'll bring it right back into view again. But that's it. A game object is just name, tag, position, rotation, and scale. And every other game object has those same properties. So if I look at a camera, remember cameras are eyes and ears in our scene. It's always there by default. It has a name, has a tag of main camera. And the reason it has a tag of main camera is you can have multiple cameras in your scene. And when you start your game, Unity determines the first camera that it finds with a tag of main camera, that's the camera that it uses. Transform. And then we have some additional components. Again, we'll talk about those next. But this is just a game object. If I create a cube, a 3D object cube, notice it has game object properties right here, and then some other stuff, some other components. If I look at something like virtual atom, here's a 3D model a company X-Ray took of me. And let's go to wireframe. And as I mentioned earlier, everything is rendered as triangles. So we can see that I've been reduced just to a bunch of triangles. And here they're pretty large. And if you look at smoother surfaces like the face, you can see they're much smaller there in order to get much more finely detailed. Now, what is an object like that? I mentioned that really a 3D object is just some points in space, triangles, and has a material that has a shader. And so if I look at this guy right here, there's essentially the clothes that I have on and my actual body. If I look at this, it's a little creepy looking because it's really me completely flattened out here. You see kind of some eyes and my hair. That's essentially what a 3D object is. We have these points in space, a material has a shader, and the shader takes an image and applies lighting to it so you can see it. Now let's go and talk about the next part of a game object next, and that's components. Components make things happen to your game objects. All of your game objects, I like to say, they come to life via components. All of what we just saw, essentially the virtual atom, that's a mesh renderer. A 2D image is a sprite renderer. There's an audio component. In other words, if you want an audio listener can hear something, an audio source can play something. A camera component. These are all just different components on game objects. For example, this wraith, this demon-looking guy here, is a game object with a mesh renderer component. In other words, it's a 3D model. It's got some points in space, and something that can take this image and wrap it around it. Everything is done via components. This Reaper Wraith has just all these components. It's a game object. We can see the game object properties here. Has an animator component, which allows it to do animations. A capsule collider for physics, so it knows which region to use for physics. A rigid body to give it mass. A nav mesh agent to give it some AI pathfinding. Some additional C# scripts on there. Everything is a component on a game object. Let's look at what they look like in real life, so to say. Game object, 3D object. Now let's go ahead and create a camera. Notice a camera is also just a game object with a camera component on it and an audio listener. That's why it acts as our ears. It has an audio listener component. If we look at essentially Atom, Atom is a bunch of game objects. It has this root game object here that has an animator on it. So if I want to play animations, if I want to give myself physics, we'll talk about physics later. There are some components for physics. But if I actually look at now what makes up my visual properties here, it's a skinned mesh renderer that actually looks at the 3D model. What is a 3D model? Again, I talked about 3D model is really just a collection of points and some information that's used to display it on the screen. Now, notice this is an FBX file. FBX is a very common file format. If you were working with a 3D artist and they give you a file to bring into Unity, most of the time it's an FBX file. It's a very common 3D file format, and that can contain this 3D model inside of it. We can see all these different pieces. And it can also contain animation data as well. So if I want this particular character to be able to run and jump, I can have that animation data here. I can also have it elsewhere as well. But everything is through components. If I go over to the 2D scene that we were looking at here, and let's go to level 1. Click on our 2D button. Very important to remember that button. 2D to go in the 2D view. And let's click on a zombie. What exactly makes up a zombie? A zombie is also a game object. We see its name. It's tagged as a zombie, and we'll talk about using a tag later. Here's a transform. There's a sprite renderer, an animator, and some code. We can ignore all this right now and just concentrate on the sprite renderer. This is what makes it essentially a visual object. That is what takes this image and shows it on the screen, a sprite renderer. So sprite renderer is pointing to an image. Now later on, we'll use the animation system to essentially swap these out at runtime. We'll go zombie idle 01, zombie idle 02, 03, 04, 05, repeat, 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 and that's how we essentially get an animated object. If I want this object to be invisible, I uncheck the sprite renderer. Let's go to that particular zombie. Uncheck the sprite renderer. Is no longer visible. It still has all the other same properties. It's still alive, so to say. You just can't see it. If I were to go to the virtual atom over here and uncheck skin mesh renderer, notice I become the invisible man, because that is what's making, that's what's reading the 3D model, taking a shader, which takes this image and does all the lighting calculations and makes it look like Adam. And if I uncheck it, if I disable that component, remember, these are all just components, Adam disappears. So components bring all of your game objects to life. Everything that you're going to work with inside of Unity is a matter of using game objects and the components on game objects. Now, when we write code, usually what you do is you get a reference to one of these components in code. For example, you ask for the animator component, and then you write code to control the animator component on this particular game object. Or if I want to do something with physics on this particular game object, I ask for its physics component, its rigid body, and then I apply a force to it to move it in a particular direction. So writing code is really just about asking for these game objects and their components and working with them via some code interface. That's it for components and game objects. It's a pretty simple concept. Just remember that everything is a game object. A game object can be a container for other game objects. That's also used for organizational purposes. For example, if you have a very complex 3D scene and you have hundreds of rocks and trees, it might be common just to create a game object called environment, drag and drop everything into that game object, collapse it up, and now you have a nice organized hierarchy on there. So game objects can be containers for other game objects, or they can be one game object by themselves, and components that bring game objects to life. If you want something visible, like a 2D image, it's a sprite renderer. If you want something like a 3D object visible, it's a mesh renderer. And a mesh renderer looks at that 3D model, uses a material and a shader, and makes that object visible. So again, it's all about components. So hopefully that filled the gap a little bit on the knowledge on components, and then we'll see you next module.